Good evening. Tonight you find me crouched in my flower beds. Why am I crouching in my flower beds, I hear you ask? Well, the answer is twofold. Firstly, my wife doesn't know where I am, so it gets me out of cooking the evening meal. But secondly, and more importantly, I want to talk to you about how my telescope works. The complete telescope is made up of two main parts, the optical tube and the mount. This, surprisingly enough, is the mount. Now the mount is quite important because our planet, like many others, revolves on its axis. It spins once every 24 hours. That's our day and night. We see it as if the sky is moving, and the sun is moving, the moon is moving, because we're fixed on the surface of the Earth. But of course what's really happening is our planet spinning. But anyway, what we need to do is be able to look at the same thing whilst it appears to move across the sky. Now the mount compensates for this rotation. It uses two motors, basically a pan and a tilt, that keep the telescope pointing at exactly the same place in the sky all night long. As to be expected, like everything else these days, it is controlled by a smartphone. I'm using a Samsung Galaxy S6. Other brands are available. That's too much, over the top. Other brands are available. Now on to optics. I own a reflector. Now there's no lenses in the main telescope at all. As the name implies, it uses mirrors. Just two, in fact. There's a huge one at the bottom, which is slightly curved, and that bounces all the light that hits it up to a small secondary mirror here, and that's a flat mirror. That bounces it through here, the focuser, and this is where you put your cameras, your eyepieces, things like that. So a reflecting telescope is really quite simple. You just need two mirrors, two very carefully ground mirrors, aligned accordingly, and then nothing in between. And mine literally has nothing in between, mainly to save weight. It's huge and heavy as it is, so this way you haven't got any extra steel that you don't need. I then cover that with a shroud to keep any other light from accidentally hitting that primary mirror. In astronomy, size really does matter. The bigger you make your objective, which in the case of a reflecting telescope is that primary mirror down the bottom, the more light you'll gather. And the more light you'll gather, the brighter the object that you're trying to look at will appear. There's another benefit to having that large primary mirror, and that is resolving power. Without going into the maths of it too much, what that means is things will appear sharper, or it means you'll be able to zoom in a bit more before things start to look blurry, and that is particularly useful with the planets. I have no idea what my wife is currently miming to me from the kitchen window, but I suspect I'm in trouble. It transpired my wife was trying to tell me that our neighbour was walking around his garden wearing only his underpants. Luckily for me, my view is obscured by a line of conifers. There is, however, a drawback to having such a large primary mirror, and that's to do with temperature. This telescope, and that primary mirror in particular, needs to be about the same temperature as the air around it, because if it isn't, that mirror will be cooling down. And whilst it cools, it will flex ever so slightly, very minutely, but enough to upset the pictures. Things will be a bit blurred and a bit distorted. So I need to get it out quite early, leave it outside for several hours to make sure it's cool when I want to start observing. So we're going to leave it here and head inside. We end tonight's episode with a bit of audience participation. After my first episode on Venus, a number of you boys and girls went and took photos of Venus yourself, and here's what you sent in. We had this fantastic picture from Danny and Mark, this tremendous photo from Jenna, which also shows the 2-day-old moon. You can see its thin crescent down the bottom there. And finally this one from a little boy called Patrick, who it seems couldn't be bothered to get up off the sofa. He has circled it in red for us though, that's very nice. Now then, I have another challenge for you. Tonight, the International Space Station is going to make a good pass over the UK. It's going to be practically overhead for people in the sort of south of England, and those of you in the north, it's still very high, 60 or so degrees above the horizon. It'll appear over in the west and disappear over in the east, so it's moving the opposite way to the way the sun would appear to move. It will look like a really bright star, in fact not dissimilar to what Venus looks like. But of course, unlike Venus, it will be moving quite fast, a little bit like an aeroplane going overhead, but you'll know it's not a plane because you won't see the red and green flashing lights either side. So it'll be a bright star, Venus sort of brightness, heading from the west, almost overhead, and disappearing off in the east. Should be visible for 3 or 4 minutes depending on your location. Tonight's opportunity to be able to spot the International Space Station is a particularly good one, tonight being Friday the 27th of March. Now depending on your location in the UK, it should appear somewhere around 7:40, 7:42 PM. So keep your eyes peeled in the west where the sun has set, and this bright star, kind of Venus-like, should start going overhead. If you miss it tonight, don't worry, it will be visible on other nights. What you need to do is Google Spot the Station, and you'll find a page on the NASA website which can give you details of when it will appear for your location. Now, how come we can see the International Space Station at all, or any satellites for that matter? Well, the answer is sunlight. They're orbiting the Earth a couple of 100 miles up. So they're so far above the Earth's surface that from their point of view, the sun hasn't yet set. Let me explain with the moon globe. So imagine this is Earth, and this is us over this side, and the sun is over here. The sun has set from our point of view because the sunlight is not reaching us. The satellites, however, are in a higher orbit. They're somewhere up here, and the sun is still catching them. So what we're seeing is the reflected sunlight off of their solar panels down here, and we are in the dark, so we can still see them because they're still being hit by the sun. Now that's why we only really see satellites dawn and dusk, because obviously they're still catching the last rays of sun, because for them the sun hasn't yet set. So that's your challenge for tonight, try and spot the station. Now do join me again for our next episode, where once the telescope has cooled, we'll be looking at some deep sky objects. For now, good night.